let's see here. Now I can share my screen. Any other questions before I move into my spiel? Okay.
I do see a couple of people in the Q&A in the chat. Can you see all those? Or do you want to wait till the end? It's up to you.
Yeah, I'll answer these for you real quick, and I'll move into the presentation. How is drought affecting our water recreation fishing? I would assume anywhere Kearney or certainly Grand Island to Lincoln and probably even the Missouri River, that's probably affected it significantly. I know we're talking to a couple of landowners, farmers from Lancaster and Seward County, like their ponds are really, really low. And they're concerned if they don't get moisture this winter, that they won't have any fish next year. And I'm assuming that's probably not those aren't isolated cases, I don't think. And I think there's, the water quantity issue is certainly probably a concern. A lot of people had to haul water from other places for livestock because they haven't had don't have the ponds. In terms of areas that have been affected worse by the drought, I would say in the last 6 months, the epicenter has shifted southward to kind of Nance County down to the Kansas border and Grand Island to about Seward. That's probably the epicenter of it. That doesn't mean that other areas of the state haven't been affected by drought, but I would say at this point, that's the epicenter of it. Is there any use of deep-rooted perennial grains in this area? I wouldn't say that's zero, but I don't have a great answer to that question. I don't think it's zero, but I don't think it's particularly common. Okay. So I'm just going to kind of start off by first going through just kind of where we were a year ago on the Drought Monitor. So for those of you that aren't familiar with the Drought Monitor, it's released every Thursday morning at usually by 7 o'clock our time, or 6 o'clock for those of you that are out in Mountain Time. And it's based on data that are through 8 o'clock Eastern on Tuesday morning. So if you get a really big rain on Wednesday morning or Wednesday night, that won't be reflected until the next week. The Drought Monitor has different categories. So none means you're in really good shape, at least in terms of not having drought. That doesn't mean there aren't other issues, but at least for that standpoint, there's no drought. Whoop. Sorry about that. The abnormally dry category is not technically drought. It's typically would be considered like a warning that you're headed into drought, or it could mean that you statistically have eliminated a lot of drought. Like in other words, like if you have had drought for quite a while and you've been getting good rain for 2 or 3 months, you in most every sense you might be out of the drought, but you might still have some decent precipitation deficits, back 18, 24 months that still would keep you in abnormal dryness. Moderate drought is, in a percentile standpoint, is I believe the 20th, like the 10th percentile. So that's I would call that more your run-of-the-mill drought. That's not necessarily would cause impacts to agriculture, but you could, depending on how timely the rains are, how much moisture you had to start a season, the impacts may be relatively minimal. We tend to start seeing more significant agricultural impacts once we get into severe drought. And that would be the 5th to the 10th percentile in terms of, a lot of different drought metrics. Extreme drought, that's 2nd to 5th percentile. So again, the extreme drought statistically should be relatively rare. Now, some places in the U.S. have been in extreme drought a lot more than 2 to 5% of the time since the Drought Monitor was released in 2000. But we're also basing this on data that go back to the late 19th century in a lot of cases. And in some cases, there's just a lot of skewness in different precipitation distributions and whatnot. Exceptional drought is the worst of the worst. So prior to last year, I don't think we had any exceptional drought in the state in 10 years. We typically don't have exceptional drought in the eastern third of the state. And I would say that, at least in terms of the Drought Monitor history, so going back to 2000, we've had the longest stretch of time in exceptional drought in eastern Nebraska easily since this Drought Monitor was released. So, for example, This time last year, Northeast Nebraska, Southwest Nebraska were kind of the worst areas in the state. There were parts of Northeastern Nebraska, like probably, I think it's a Stanton County. I think there are parts of Stanton and Wayne counties that were in exceptional drought for almost a calendar year. I think maybe 10 and a half months. They finally got out of it this summer. Now, they've had significant improvements up there recently, which I'll talk about here in just a second. But again, we had one of our driest years on record last year. So we were above average, for the year as a whole, and we were very, very dry. And I would probably go so far as to say that if it wasn't for parts of East Central and Southeastern Nebraska actually having decent moisture from late April, the first part of July last year, we probably would have been closer to second or third worst on record. So last year was, by historical standards, really, really bad. And that's why we were in the shape we were in to start this year. So where we are currently, for a majority of the state, things have improved significantly. So you'll remember that last year there was places that in southwestern Nebraska that were in exceptional drought, and a lot of northeastern Nebraska. So we have parts of the state that have gone up 5 categories from exceptional drought to none. That is tremendous in a year's time, and in some cases that's happened in over the course of 3 or 4 months, which is really, really good. So pretty much anything or anywhere in the white, or even a lot of cases of yellow, things generally are in pretty good shape. And I'd probably go so far as to say that even some of the areas in northeast Nebraska where you see moderate and severe drought probably in a lot of cases have had good enough moisture in the last month that there's decent moisture, going into this winter. It's a very different story once you get south of Platte, or certainly once you get down to about Fullerton. So, again, we still have very, very bad conditions in this area. And we've been very dry in the southeastern part of the state in the last 6 weeks to 2 months. So I would anticipate actually seeing a little bit of degradation in parts of southeastern Nebraska on tomorrow's map. So again, it's going to take a little bit different look at this. So on the Drought Monitor's website, they have these change maps, from 1 week, 2 weeks, a month, so on and so forth. So going back a year, so October, Halloween of this year to November 1st of last year, really, really good improvements across the state. So again, I think for the most part, this has been a very good year for a lot of Nebraska. We've really improved a lot of the pasture conditions out west. We have set the stage for this year to have at least the prospect of having a pretty good wheat crop. The ratings on the current wheat crop in the state are pretty good. They're not the best they've ever been, but they're a lot better than they were last year, and they're generally better than they've been since 2019. But as bad as things are in some parts of the state, and they were earlier in the year, we probably averted what I would call, I don't know if I say a total crop disaster, but we were probably in late June, we were staring at having the worst year that we would have had off trend probably at least since the 1950s. And you probably might have to go back further than that. So if you remember, back in May, we had really good precipitation across the western third of the state, and we really made good progress on drought. Once you got to about Kearney, though, it was generally pretty dry, and it was acutely dry once you got to about Grand Island and toward the eastern portion of the state. The very far part of the very southeastern corner of the state did have some moisture to work with early in the season, so conditions were not quite as dire down there. But pretty much anywhere from Lincoln to Grand Island and Norfolk to the Kansas border, I mean, we were looking at needing rain in the next week or else, and I mean that literally. But by early August, because we did have really good rains in a lot of the eastern portion of the state, you'll notice that we actually, according to Veg Dry, were in really pretty good shape here across the southeastern corner, and had some indecent, at least meaningful improvements across portions of northeastern Nebraska. Didn't really see as much improvement here in what I'm going to call like southeast central Nebraska. But again, I think you had really poor yields and historically poor yields in some cases, but I think you still had some crop. I think were it not for the rains in July, we probably would have had almost nothing on rain fed in that area. And I think you would have been, you probably had a lot of irrigated farmers would not have been able to have a whole lot either, because you had some areas where they were put on significant restrictions because of very low stream flows. Just to kind of take a look. So actually, let me take a step back real quick. So I failed to mention VegDry. For those of you who are not familiar with it, this is a product that was developed at the University of Nebraska in conjunction with USDA, and I think NASA had some input into this. So was an RMA. But so anyway, this is a joint effort quite a few years ago. It started in Nebraska in the north central region of the country, and is I think in 2008 or 9 expanded to cover all of the continental United States. VegDry combines satellite reflectance data, so spectral reflectance data and climate data. So it basically tries to take a look at the direct impacts or direct measurements of vegetation health, and then also combines that with different climatic variables. So it kind of tries to take a relatively holistic look at vegetation health. And I would say in general, once you get to about mid-June through like late August, early September, in general, it's a pretty good reflection of vegetation health. In some cases, it might show up as drought when there are other issues causing a crop to be behind schedule or to have poorer health. But I would say 8 or 9 times out of 10, if it's showing a lot of red and yellow on the map, it's because there is some amount of water stress on the crop compared to an historical average. So COCORAS is, if any of you are into citizen science, COCORAS is a phenomenal citizen science program that was started at Colorado State about 25 years ago in response to a really, really bad flood that they had. So the main goal of the program is just trying to get more people observing precipitation measurements. Because there's only so many automated stations around the country. We do have a Mesonet in Nebraska that has reasonably good coverage, but doesn't cover everywhere. And clearly we don't have observations everywhere, but these observations do make a difference. They do go into the pipeline of data that helps make decisions on U.S. Drought Monitor, things like that. But you'll notice that for large portions of state from June 25th to August 6th, there are a lot of places that had 6 to 8, almost 10 inches of rain in some of this area. Now, again, there's probably parts of York County here. They probably had more rain in 4 or 5 week period than they had the entire rest of they probably had double the amount of rain that 4 or 5 week period they've had the rest of the year combined. But the point being is, like, we did get enough rain in a lot of the state to actually divert total disaster. In some cases, actually, especially once you get into Cass, Odo, and Richardson counties, I think there was actually some pretty reasonably good corn yields this year, at least compared to 2022. So I want to move into what we would refer to as flash drought. Now, I'm going to assume that a lot of you by now probably have heard this term used in the media. The media sometimes uses it correctly, but as the case of media, they oftentimes use it in incorrect context or just blow it out of proportion. And so it is technically drought. It is a subset of drought. So there's different, like meteorological drought, there's hydrological drought, agricultural drought. So flash drought is basically kind of a specialized subset of drought that is distinguished more by its really strong rate of intensification. So it implies a strong warming heat signal. So there's a very uncommon winter event, just because of the winter you typically don't have the warm enough temperatures to really deplete soil moisture and those sorts of things. So flash drought has to kind of account for its rapid intensification, but it has to actually statistically be considered a drought after, say a 3 or 4 week period. So, I mean, it really is something that lasts at least a month. Generally, we kind of think about flash droughts as being in that sub-seasonal to seasonal time frame. They are. I've spent a lot of my career, probably, which is, at this point is over 10 years, studying these things. I find them incredibly fascinating, and there are places in the U.S. that are around the world that do tend to be a bit more prone to these than others. But they do tend to be warm season events, and they also do tend to occur a bit more, with more frequency in places where you have agriculture, especially row crop agriculture. So some of the places where we have our most important staple crops, or at least the most important commodity crops, there's a relatively strong overlap with flash drought. For anybody that wants a reference on, so the flash drought was originally coined by Mark Sabota, the National Drought Mitigation Center, probably about 20, 21, 22 years ago. But a group of us got together in 2017 and 2018 and wrote a paper in BAMS because we really kind of want to actually put down some definitions on paper and actually try to get the community to come around to some consensus on what it is and what it's not. So it's not, a 10-day dry spell or a 2-week dry spell. It needs to be something long enough that it can statistically be considered a drought and actually have, some statistical meaning to it. So if you haven't picked up on this yet, drought in a lot of ways is very much based on some, different statistics or metrics. So in terms of measuring flash drought, so for full disclosure, I help make recommendations for the U.S. Drought Monitor every week. So I send, my recommendations to U.S. Drought Monitor author every week. There are a number of different authors, so it rotates between the National Drought Mitigation Center, the USDA, NOAA. I believe there's a couple other agencies that are involved. So there's like about 5 or 6 different main authors, and then there's about 3 or 4 that I would say are sort of secondary authors. So it's almost kind of like you have your starting 5 for basketball, then you have your 3 or 4 that are sort of role players that will come in and step in if they need to. But there are a lot of tools that we can use to help kind of make decisions. So the HPRCC, which is the High Plains Regional Climate Center, it's a NOAA regional funded center that's based here in Lincoln, and they have a tool set called the Spatial Climate Analysis, and in there you can access things like a standardized precipitation index, temperature departure for normal, precipitation departure for normal, and other sort of drought indices to kind of give you an idea of how things are shaping out. Then there's a product called Quick Dry, which is similar to Veg Dry. The difference is that Quick Dry is based on a lot more short term. So so it's very heavily weighted toward 1 and 2 month climatological data, not longer term like Veg Dry is. But the reflectance data are mostly the same. Just for other papers, so I've published quite a few papers back in days when I was still doing more research. So Flash Drought 1936 is a paper that's open access in the Journal of Applied Service Climatology. That was sort of a early COVID activity. So when we went into more shutdown mode in March of 2020, I decided for keep my sanity. It's like, well, I want to take a look at a really, really bad drought that affected the U.S. and just see what if we really are thinking about things like 2002 and 2012 and 1988 of those things being sort of the worst. And what I found was that years like 1936 actually were considerably worse. And if we think, that we probably ought really in some ways should prepare ourselves for something that was that bad. And I would add that where we were sitting in late June was we were headed down a path that way. At least we were heading into a period that we could have started seeing conditions we hadn't seen since the 1930s. As it was, we were seeing things we hadn't seen in some cases since the 50s. Just real quick, this is a poster that we presented. So Lauren Lohm was a colleague of mine down at Wake Forest. Obviously, I'm no longer with AER. They were technically based in Lexington, but I worked for them for about 11 years before I joined Extension earlier this year. But this is just kind of a look at the 2012 flash drought. So, again, we had really, really big impacts on corn and soybean yields in a lot of the Corn Belt. Really rapid intensification. And what we were kind of trying to do with this was just trying to take a look visually if we saw propagation of flash drought, which we kind of found is that it had its origins more like the lower Mississippi, Ohio valleys, and sort of shifted toward the west and north through the season. And by late, mid-fall, your worst conditions were more like Nebraska, North Dakota, South Dakota, and things that improved quite a bit as you got into parts of the mid-south and southeast. And this is actually not an unusual phenomenon. So a lot of our really significant droughts have their origins to our south and southeast. I know that probably is a bit of a misconception. I think we tend to think weather patterns will come from the west. But if you think about it, though, our fetch of moisture tends to come or good moisture does tend to come from the south and southeast. And in the summer, we do get some northwest flow that can sometimes give us storms. So if we have drought to our south and southeast, and if we have things off to our north and northwest, that can actually be a really good indication that things are you might be at an extra high risk for flash drought. If we go back to 2022, we saw exactly that. We had existing drought across a lot of central and western Nebraska and to the north of, say, the Omaha-Lincoln metro areas, and we had drought that was developing relatively rapidly across portions of Missouri and Kansas, Oklahoma, and Arkansas. And what we saw as the summer progressed is we saw that spread north and intensify in a pretty significant way in our part of the country. Again, the atmosphere is the one that's really driving this. I mean, there are different mechanisms that will allow for stronger upper level ridges that will tend to suppress precipitation for longer periods of time. But there are a lot of land atmosphere feedbacks that I think we're still trying to get a better understanding of that probably, in some cases, may help alleviate flash drought conditions, but probably more often make worsen conditions, what we would kind of refer to as a positive feedback. So just in terms of where are the hot spots, so this is a paper that my colleague down at University of Oklahoma published in Nature Communications a couple of years ago. So we did this in like 2020, early 21. And using something called the standardized evapotable stress ratio, we try to identify parts of the globe where we saw hotspots of flash drought. So things where they were occurring with a bit more regularity. And what we tend to find is that they tend to be in areas where you have agriculture is important, where you tend to have a lot of row crop agriculture, and or you tend to have a very distinct wet and dry season that often is tied to a monsoon. So in other words, if that monsoon is late by, say 3 weeks, you can have significant precipitation deficits. So again, that's why you probably see India as a hot spot. That's why you see parts of Brazil, the Amazon region as a hot spot. Same thing with equatorial Africa. I mean, you tend to have precipitation there can be not as reliable as it is in other areas, say in some of the mid-latitude regions. So they are a bit more prone to flash drought. And you also tend to have in those areas, you tend to have a strong temperature signal, which can exacerbate conditions. In the mid-latitudes, again, so you'll notice like the central U.S., so our area, so basically kind of central Nebraska to the Great Lakes is kind of a hot spot. Iberian Peninsula is a hot spot, and you'll notice this part of kind of eastern Ukraine, southwestern Russia is a bit of a hot spot. They had a horrendous, I think one of the worst flash droughts I've seen in the modern era was in southwest Russia in 2010. We wrote a paper about that. I try to think of the name of it now. Been a few years, but anyway, what we basically found was that it was a situation where the timing of the flash drought was optimal in the sense that it affected their spring wheat and winter wheat crops in a very, very significant way. And at that time, the Russian government decided that I think they had just passed something earlier that year where they were wanting to ensure more of their own food security. And because of that act, there was this pressure that they were going to put on an export ban because of the anticipation of how bad the drought conditions were in that area. And in anticipation of that, you had a very significant increase in the price of wheat on global markets. And in places that were very, very reliant on grain from Russia, so for example, Tunisia, Egypt, Turkey, I think there were some other countries that were mostly more we would maybe classify as the Middle East or Lebanon regions, were very reliant on grain from Russia. So their prices increased incredibly almost overnight, and you saw a rapid increase in poverty. And it was probably, to some degree, is considered one of the last straws for the Arab Spring of 2011. So sometimes droughts that occur in one area can have significant global impacts. So in terms of where we are headed with regard to climate change, this is a study that was published earlier this year in another Nature publication. And what we did is that we decided to take a look at different emission scenarios and to determine, what does flash drought look like under, say, more of a lower emission scenario, which would be the 126, a higher emission scenario, or maybe like a more moderate emission scenario, or probably more realistic emission scenario in 245, and probably the worst case scenario with 585, which I would say at this point we are probably avoiding. So the last two numbers on those are the most important: 2.6, 4.5, 8.5. That is basically that number means it's the extra watts per square meter of extra radiative forcing. So the sun is by far the most important source of radiative forcing. It's about, at least when it comes to top of the atmosphere, it's like 1,367 watts per square meter. But even 2.6 watts per square meter of extra radiative forcing is not trivial. 8.5 extra watts per square meter of radiative forcing is going to be an interesting challenge if we end up meeting that. I think we're going to avoid that, but I think we probably should buckle down and hopefully you can get that 4.5. Because that will still be problematic, but probably will make things a little bit more manageable. At least that's my hope. And I'm probably, by nature, a bit of an optimist. So I'm going to shift a little bit into agriculture, since I know this is probably near and dear to a lot of your hearts. So if you take a look at just the different, just different land cover classifications, you'll notice that anything kind of in the brown area is considered more cropland, anything in green is considered more grassland. Now, clearly, there's more of a mix of crop and grass in here that's depicted here, but you kind of get the point. There tends to be a lot more pasture and range and small grains. In the western third of Nebraska, we tend to have a lot more of our commodity crops in the eastern half of the state. And kind of the same thing through Iowa and Illinois. You don't tend to have, there's not much tall grass prairie left once you get into those states. So in terms of our soils, again, so I wouldn't take the map on the left to be purely literal. I mean, that's kind of based on a couple different data sets, and there's some interpolation that went on to this. But regardless, the area in blue are places where you tend to have our healthiest soils that tend to be deeper and hold more water. And those are areas where you tend to, especially here and further east, is where you tended to have really the tall grass prairies, and that were there for long, for centuries, and those help to develop really good, rich soils underneath. And that's where you tend to this day still have a lot of water holding capacity. So again, that's why we tend to have a lot of the crops that we do here, is because they do tend to kind of grow fairly well here. So when you think about what the Corn Belt is, this is a definition that sort of changed over time. So if you're going back to the first half of the 20th century, or probably even through the 1970s, a lot of people, only really considered the I-states plus parts of Ohio and then, maybe parts of Nebraska to be in the Corn Belt. South Dakota was pretty marginal, and North Dakota, anything north of probably, say, like southwestern Minnesota, was kind of considered to be extremely marginal if there was anything grown at all. And what we have noticed is that we've seen a pretty strong northwestward shift in corn production. Not that we still don't have corn production in Ohio and in Kentucky and those types of places, but we've seen a dramatic increase in corn and soybean production in places like eastern South Dakota, eastern North Dakota. Some of that's just cultural. A lot of that, though, is we have genetic varieties now that are able to put out a high yielding crop with their shorter growing seasons. And this also is a reflection of growing seasons are on average starting to get a bit longer up in that part of the country. So they are able to grow more corn and soybean south of Fargo. If you would have gone up there 40 years ago, you had not seen probably any cornfields. You would see mostly spring wheat, maybe some barley, some oats, sunflowers, and those types of more of their traditional crops up there. But there are some publications that basically consider the western edge of the Corn Belt to be basically about Lincoln, or maybe just kind of up here parts of northeastern Nebraska. And again, this would be more of what we would call the kind of the edge of the rain-fed Corn Belt. But again, this is published in the late 90s. So at that point, you still did not have much corn production up in this region. The good aspect of having more corn production in those areas is that it does tend to reduce the probability of having the entire region fail at once. Now, you do occasionally have droughts that do infect the entire region, like 1988 or 1936. But even in 2012, the difference is that we had more corn production up in the northern part of the Corn Belt, and they probably actually made the U.S. production numbers higher than what it would have been had the same drought occurred 30 years earlier. Again, I found this map earlier today. This basically kind of shows anything in the darker yellows is really have the most intense production of corn. And again, this is really kind of where you have the right soils and the right overall setup, I would say, for strong corn production. So again, the northern half of Iowa, parts of eastern Nebraska where we have irrigation. So Grand Island, Hamilton County, York County, those are probably typically some of the biggest corn producing counties in the country, or I'm sorry, in the state. Sometimes they can be the country. Then you get a lot of corn production in Illinois and Indiana, and even southern Minnesota. So southern Minnesota is a lot like eastern Nebraska in a lot of ways, and this kind of reflects that. And notice a significant decrease in that once you get into Kansas and Missouri, and you'll notice there's parts of it in Texas. But anything that's here in southwestern Kansas or Oklahoma Panhandle, again, this is all, or northeast Colorado, this region is all irrigated and all extremely heavily irrigated. You basically cannot grow a reasonable crop in most years without irrigation. In a lot of cases, it's probably excessive irrigation, is my opinion. So in terms of land cover in the state, now again, this map is a good 18 years old, but I still think it's really instructive. I also probably point out this map has probably changed a little bit since then, since this is probably just kind of the very beginning, or probably just before the big ethanol boom, where we had more conversion to corn in some places where you traditionally didn't see it. But anything that's kind of in these lighter green pixels, so what you see here in southeastern and parts of east central Nebraska, these are all rain-fed corn, soybean crops. The reds would be more of your forest cover that you see, something more riparian forest. You do tend to have more trees just in general down here in southeast Nebraska. So what we have kind of east of Lincoln and south of Platte River, in general, is a lot like what you would see in what we call the I-states, Iowa, Illinois, Indiana, and the farming there is a lot more like it is in those states. A bit more of a mix of rain-fed and irrigation up here in northeastern Nebraska. Anything here in this kind of darker green, that's indicated where you have center pivot irrigation, or just irrigation in general. And you'll notice that once you kind of get past the Blue River, it's right around Seward, where you see this really kind of sharp transition to center pivot agriculture. And you'll notice here there's a lot of irrigation kind of right along riverways here, kind of on the southeastern edge of the sandhills. This brown would be more of your pasture range conditions. The blues are where you would tend to have your natural wetlands. And these pinks and other types of colors are more reflective of small grains or specialty crops. So you tend to have more wheat and dry beans and sugar beets and things like that out here in the Panhandle. You do still have some irrigated corn. I think you're even starting to see a little bit of soybean growing out in that part of the state, but it's still pretty unusual to see that. But the agriculture in Nebraska actually is a little bit more diverse than people give it credit for. I think when people think of Nebraska, I think they tend to think of York County, Hamilton County, where you have a lot of irrigated corn and soybean production. But Nebraska still is a pretty important wheat producing state. And you do tend to have a lot of wheat here kind of along the Kansas border. Southwestern Nebraska and the southern part of the Panhandle are still pretty big winter wheat producers. And we do have other crops here that are grown. So I would say our agricultural or production has more diversity than what we would see, say, for example, in Iowa or Illinois, where Iowa basically is almost exclusively corn, soybean, other than maybe some smallholder farmers that are growing other specialty crops for like farmers markets and things like that. So, but because we do have irrigation in the state, we do have a lot of pivots, and we have a lot of groundwater, and we have a lot of wells. So this is an updated map from our Conservation Survey Division, which is hosted in the School of Natural Resources. And what you'll notice is basically anything in wider places where you, in general, don't have any irrigation. So, for example, Cass County, which is to the east of Lincoln, almost no irrigation down here in Richardson County. A little bit here near the Missouri River, kind of Blair, Decatur, that area. But in general, the very eastern sixth of the state, very little center pivot irrigation. You'll notice it more along the Platte River here, kind of west of Fremont, north of Wahoo. The highest density of irrigation in the state, though, is kind of here in Merritt County and west of Grand Island. I think Aaron Young, who is the one that really is probably the most active in taking the groundwater measurements and making this data set, helping make these maps. So these are probably some of the highest density of irrigation wells anywhere in the U.S. So again, Nebraska has more irrigated acres than any other state in the country. I think we surpassed California at some point in the last 10 to 15 years. And our most heavily irrigated portion of the state, again, is mostly kind of Lexington to Seward and south of Fullerton. So again, this region, you get pockets of it out here in the Panhandle and parts of southwestern Nebraska. And one of the reasons for that, so the main reason you see this map is that the Ogallala basically doesn't extend any further east. So geologically, this part of Nebraska is very, very different than over here. So you have much more readable access to groundwater in this part of the state for irrigation. And the other reason is once you get into the southeastern corner of the state, you really almost don't need irrigation because you generally get enough precipitation in a year to grow a pretty good crop. Again, so Falls City down here in southeastern Richardson County is about right at 36 inches of rain in a year, which is about the same amount of rain you have in Des Moines or in the Quad Cities, for example. Here in Lincoln, we're sitting just a bit under 30 inches on average for the year. Grand Island's probably sitting at about 24. North Platte's probably sitting in the low 20s. And you get down to Panhandle, you're definitely kind of under 20, and probably a lot of years you're lucky if you were in that 15, 20-inch range. Now, this year is a special occasion, so Chadron actually has had more rain than Lincoln and Omaha. Chadron is close to having its wettest year on record, and we are decently below average in this part of the state, hence the drought. So in terms of groundwater changes, so pre-development, which I think we would consider probably the 30s or certainly before the 50s, and I forget exactly what they are defining as pre-development, but certainly it's, probably if you go back a century before anybody started really tapping groundwater, let's say to grow crops, where we've seen our biggest declines are here around Alliance and Box Butte County and south of Ogallala. I think it's Perkins, Dundee, and Chase counties where you've seen our biggest declines. We definitely have seen declines in other parts of the state as well. But what's interesting about this area, according to Aaron Young, is that this is an area of the state where we have seen, or we tend to see the most fluctuation. And we see that just because, A, there's, a lot of agriculture in that area, but also you do tend to have enough precipitation in some years where there's a lot less water being withdrawn, and you do tend to get a lot, a bit more recharge back into the groundwater. So that helps. The other thing that I think Nebraska, I wouldn't say we do it perfectly, but I think that what we should be commended on is that 50-something years ago, we developed natural resources districts by watershed, and we have given them the authority to have some regulations and whatnot. And, again, we've seen significant declines in groundwater in this region, but according to the geologists, they are really in danger of running out of water anytime soon in this area, even though the declines are pretty significant. But he was saying yesterday at the Climate Assessment and Response Committee meeting that you get down to Kansas and Oklahoma and Texas, they're seeing declines in groundwater. They're more than double what we've seen anywhere in Nebraska. So the fact that we have had the infrastructure or the social infrastructure in place to put the regulations on to monitor groundwater in a much more efficient way has probably really helped us preserve, our access to groundwater to allow us to maintain, allow us to grow crops under irrigation for well into the future if we choose to do that. Just for comparison, again, that's not what the data here are not apples to apples. What we see here in Kansas, this map is from a New York Times article. It was published back at the end of August. It's a very good article on groundwater use in this country. If you haven't read it yet, I strongly recommend taking a look at it. But Kansas is in a much, much more dire situation with regard to the ability to irrigate than Nebraska is. Some of that is because they are further away from the source of recharge, so they did not have as much groundwater to begin with as they did in a lot of Nebraska. But part of that is it was just basically the wild, wild west with regard to irrigation use in that part of the state, or in Kansas. And because of a lot less judicious water use back in the 70s, 80s, 90s, they now are in situations where they don't have much water, and farmers are having to kind of go to extreme deficit irrigation or go to rain-fed farming. And if you've ever been to southwestern Kansas, rain-fed farming is a very difficult proposition. Maybe 1 or 2 out of 10 years, you might actually get, a 60, 70 bushel acre corn crop on rain-fed. You just don't have it's just too hot and windy down there. You just don't necessarily start the year off a lot of moisture. The nice thing is you get in the eastern part of Nebraska, this year notwithstanding, is we tend to have decent moisture in the soil going into the season, which, we tend to get rains a little bit better timed in this, a bit more rain in the spring and a little better times than, August and September. So it's a lot easier to grow rain-fed crops up in this part of this, this area. So this is kind of what we consider the edge of the rain-fed corn belt. And again, this is really reflected, and this is why the map looks this way it does. So in terms of trends, so again, this is not incredibly recent, but if we take a look at how trends were going starting in the early 60s, so in this paper that we put together, I guess we got it published in 2020, but we did it on data up until 2018. What we noticed is actually the strongest yield trends, at least during these periods, tended to be in areas where where corn production was tended to be a little bit newer. So again, there was a little bit less corn in this part of this country in the 1960s, and so you tend to have a little bit more sorghum and winter wheat, and so it's possible that maybe we just got a premium for the first 40, 50 years with having soils that are a little bit more amenable to it. But it's also a reflection of that in general, our area of the country last year's notwithstanding has gotten a little bit wetter. It's also a reflection of genetics have allowed corn to do a lot better in, say, parts of eastern Nebraska and eastern South Dakota and Minnesota than you would have had, say, the 1980s. Your traditional areas of highest production were generally back in the 60s and 70s, were Iowa and Illinois and a little bit of Indiana. As we get into more recent times, Minnesota is a lot more important. Nebraska is more important. Iowa is probably a little bit less important, even though it still is, very, very important state. Same with Illinois. Indiana has become proportionally less important. Same thing with Ohio. More as North Dakota has become a little bit more of a little bit more prominent. And then the last thing I kind of want to mention in this talk is when I started this job, I inherited this climate smart ag program called Weather Ready Farms. And one of the main goals of this is actually to help agricultural producers and others in the agricultural community to understand the risk of extreme weather from just extreme weather in general, but also just things that would change, what will occur because of climate change. So we want people to just get really understand what their risk is of different perils like drought and hail and early frost and flooding and you name it. And then to actually come up with some mitigation strategies of how do you avoid, do you make changes based on this? Do you maybe plant a cover crop? Do you maybe not? You take a look at your high resolution data that you're getting from drones to see, okay, what part of your fields are most fertile, and maybe you don't plant or don't put as much nitrogen in places where you have really good soils and so on and so forth. So I probably have rambled on long enough. I still have a bit of time for some questions, though, if any of you guys have any. Thank you for listening, and anyway, thanks.
Yeah, thank you so much, Eric. Really quick, before I send over the Q&A to you, I'm going to launch our survey. So I mentioned this at the beginning. If you weren't here at the beginning, it's a very quick, just a couple of question survey. Shouldn't take too long. So let's see.
So I missed a question from Michael. Does the record reset at the start of each year, or is there a cumulative measurement period? I don't know. I'm not sure exactly what you mean by that, but with precipitation, we tend to look at things over a lot of different temporal periods. So like, for example, one of the things I take a look at is I look at the 18 to 24 month precipitation deficits and accumulations, if that makes sense. But for example, we always take a look at annual precipitation. So for most of the state, I would say almost everywhere in the state has had more rain in 2023 than in 2022. The problem was it was so dry last year. It was really, really dry this spring. So a lot of places just were really behind the 8 ball to start the growing season. So like, for example, you can have a dry spring if you have a really good reserve of moisture. So for example, if you unfortunately get laid off, or if you have some financial you have some short-term difficulty financially, it's like if you have money in the bank in savings, then you can at least live off that for a while. I.e., an agricultural analogy is having good soil moisture. If you don't have that, then you really just don't have anything to work with. I don't know if that's a great analogy. That's the best one I can come up with at the moment.
And then Eric, can you see those questions in the Q&A section too?
Yeah.
Okay, awesome.
Actually, hang on. Let's see here. Yeah, I see now subsoil beneath my house. Now I have cracked floors. What can be done to mitigate further damage? Boy, I'm not the best person to answer that question. Well, I'm trying to think who the right person would be. I would probably there's probably some work that could be done with the soil to maybe help it. I'm trying to think. Yeah, I don't have the best answer for you there. Best action someone in a residential neighborhood could do to address dry conditions. My best advice is with regard to your typical lawn or yard, mow high all the time and just be judicious with your water use. You really actually don't have to water the grass. It's actually not good for you to water the grass constantly. You want it to occasionally breathe, and you want it to dry, get the deeper roots. Mowing it higher tends to allow it to have deeper root system, which allow it to be a little bit more resilient when you have drier conditions. So that's probably my first advice. There's also more, depending on where you are, there are certain varieties of sod that are a little bit more drought tolerant. And I would just make sure that if you have water restrictions, just focus your water on your most sensitive vegetation. So your shrubs, your trees, those types of things, especially anything that's really good for pollinators. The grass, honestly, you'd be surprised it would come back in 6 months if you have a good wet period. Even this summer, for example, we had neighborhoods in Northwest really doesn't water at all, and their yard was essentially about dead in early, into June. And all that rain we had this really mid part of the summer, it actually really came back. It looks not too bad right now. Do you factor soil water infiltration ability in development of drought maps? Yes, we do. But I would say soil moisture, I would say the soil infiltration ability probably is a bigger factor in trying to determine like what your yield loss will be in an area. So places that have better water holding capacity or that have better infiltration ability are going to have less, or going to have but more minimal impacts. Maybe not minimal impacts. Their impacts will not be as great on crop loss as places that can infiltrate water as well, if that makes sense. But that is a consideration. Soil moisture, I consider to be a very, very important variable, because to me, soil moisture is sort of ground truth for the precipitation. And what we saw a lot of times this summer is we had heavy precipitation events that were somewhat good at recharging the soil, but they only really recharged maybe the top foot or maybe foot and a half in some places. And we really just were, in a lot of cases, we're not seeing that evidence of deeper recharge. And what you kind of saw in August when we had that heat wave is that we didn't have that really deep reserve, and it was so hot that we depleted a lot of things really quickly. So that's one reason you saw things turn really quickly. The other reason is roots in a lot of cropping systems this year, from talking to people extension, were just never that deep to begin with in a lot of places, because there was not enough moisture to start the year. Roots are only going to go down as far as there's water. So if you don't have water in May or early June, or in the month of June, those roots may not go down that far, because they're not going to preferentially go down in anticipation of having water. But it's not there. They're not going down. If there's water deep down there, they'll keep going as far down as 4 feet in some cases. But we did see a lot of very shallow tap roots on soybean this year. I think we had saw some of the same things with corn. And that might have been one of the reasons you saw more corn blown down with 60, 70 mile winds in parts of the state this year. What and how can Nebraska fully develop the mesonet? So UNL and Nebraska are fully helping ag and urban. So I think we are hopefully in the process of getting the legislature to fund substantial upgrades and improvements to the mesonet, just in terms of density stations and in terms of products that we could offer people in the state. So I think that's going on, but seriously, if you know your state senator, or if you know somebody in a state in your NRD, or somebody state department of ag, please tell them that you want you really value the weather data, because that will go a long way to helping make sure this gets done. Squeaky wheel does get the grease, and the more residents of the state that are saying, hey, this is important to us, the easier it is to get this done. How much does a good crop need if fully rain fed? I think in general, a corn crop probably depends on where you are. At this latitude, north part of the country, you probably would want at least 18 inches of rain in the growing season. You probably ideally would want at least somewhere in the 20, 24 inch range. Now, you really don't want over 30. You certainly don't want like 40, 45 inches of rain like we had in 1993, because then you start dealing with flooding issues and anaerobic soils and things like that. In some cases, can be even worse than drought. But yeah, I mean, over the course of it, the corn crop, I think, will use 18 to 24 inches of water, depending on demand. So some of that you could have in the soil begin the year. So you can have a little drier year if you have the good reserve to work with and you get the rains at the right time. Timing of precipitation is actually incredibly important, which is another reason I like looking at soil moistures. I try to just see, like, okay, are we continuously actually keeping some moisture in the soil? Particularly the top part of the profile, because there tend to be more roots in that top part of the profile, and it's easier for the crop to actually use the water that's there. Do you believe we have data to support long-term weather and climate change? If you're asking if we have long enough data to say we have climate change, yes, we do. What is the status of Ogallala Aquifer? My diagnosis, or what I can gather is based on data and talking to people that are more of experts in that field. We're probably okay in Nebraska for the most part. I would say that with some degree of confidence, but a lot of the southern high plains, they are in dire straits down there, and I think you'll have to see some land conversions, just because they won't be able to continue to grow. You basically have to almost put on 24 to 30 inches of water to grow corn crop in the Texas Panhandle. That's just simply not sustainable. So I hope those. Anybody else have any other questions?
Yeah, there are a couple in the chat, so
Rain
people are kind of using both. Yeah,
for basement flooding. That might help a little bit. I mean, my guess of the basement flooding, it might mean that you're in an area that preferentially maybe floods a little bit. Sump pump probably would be at least that's maybe the most direct, simple option, or maybe not cheap option, but it's probably one. But there's probably other things that you could do, maybe to build up the ground and work the soil around your property, that maybe would help. So yeah, rain garden may actually help with that somewhat. Nebraska's statewide drought plan is over 20 years old, and really not all that good. I would just say that when it was developed, it was a very state-of-the-art drought plan. It has not been updated in a long time, and I will tell you that something that got brought up yesterday, the Climate Assessment Response Committee, I think that's something that will be addressed in the next couple of years, hopefully the next year. So again, I anticipate seeing an updated drought plan. And yeah, thank you for that. I think that's, I think there probably actually should be a state statute in my mind that says it has to be updated a minimum of every decade. This is, we are going to continually have more and better sources of information that could go in the drought plan that would have triggers to say that, yeah, we need to do X, Y, and Z once we hit certain thresholds. Why the increase in water levels in south central Nebraska? I think that's might be water moving from other sources into there. I mean, I don't think that's necessarily a reflection of. I don't remember the exact reason for that, but it had something to do with water movement. Again, I'm not a pure hydrologist. I don't know the specific reason, but I kind of remember Aaron saying that yesterday. But I would not view that as a reflection of they just stopped irrigating in Phelps County. That's not true. But they do have access to more groundwater than they probably did 50 years ago. Yeah, sorry if some of the questions you asked, I couldn't give you the best answers, but I don't want to BS you too much if I don't really know the answer.
It looks like that's all of them.
Irrigation. Yeah, that might be the case. So, anything else? Again, thank you for having me on. It was a pleasure to chat with you guys tonight. And again, if any of you are ever on East Campus in Hardin Hall and want to stop by and chat, just come by. I'm housed in the state climate. My office is in the same area, the state climate office in the north wing of Hardin Hall on East Campus.
Awesome. Well, thank you so much for taking your time out of this evening to present. I learned a lot, so I hope that everybody else did too. So thank you so much for being here.
Yeah, you're very welcome, Kean. Thank you.
Yeah. All right. Well, have a good night, everybody. Thanks for joining on.
Yeah, bye.